Welcome to Build Smart Nigeria. Today we're tackling one of the most critical stages of any building project, casting the concrete slab. This isn't just about pouring concrete, it's about laying the very foundation of your structure's strength, safety, and longevity. A poorly executed slab can lead to catastrophic failures, costly repairs, and endless headaches down the line. But get it right, and you've built a solid base for everything that follows. In this comprehensive guide, we'll walk you through every essential check you must perform before a single drop of concrete is poured. From preparing the site and erecting flawless formwork to correctly placing reinforcement and services, we'll cover it all. By the end of this video, you'll have a professional-grade checklist to ensure your next slab is a masterpiece of engineering. Let's get started. Before any formwork goes up, your first priority is site readiness. A solid slab needs a solid base. Start by thoroughly clearing the entire area of all vegetation, roots, and topsoil. This organic material can decompose over time, creating voids under your slab and leading to settlement and cracking. Once cleared, the ground must be properly graded and compacted. This isn't a step to rush. Use a mechanical compactor to achieve a firm, stable base that won't shift under the immense weight of the concrete. Pay close attention to drainage. Ensure the surrounding ground slopes away from the building footprint to prevent water from pooling against or under your foundation. Finally, establish clear and safe access routes. You'll need space for concrete delivery trucks, wheelbarrows, and workers to move efficiently without disturbing the prepared ground. A well-prepared site is the first sign of a professional job. Next, we move to the formwork, the temporary mold that will give your concrete its shape. This is where precision is paramount. Your formwork must be strong, rigid, and perfectly aligned. Use high-quality timber or steel panels that are clean and straight. Check every joint and connection. Are they secure? Can they withstand the immense lateral pressure of wet concrete? A common point of failure is inadequate bracing. Ensure you have sufficient diagonal and horizontal braces to prevent any bulging or movement during the pour. The vertical props, or shores, must be plumb, spaced correctly according to your engineer's drawings, and placed on solid ground with sole plates to distribute the load. Use a spirit level and string lines to verify that the top of the formwork is perfectly level across the entire slab. Even a small deviation here will result in an uneven floor. Finally, inspect for any gaps or holes. Seal them meticulously to prevent grout leakage, which can weaken the concrete and create a honeycombed, porous finish. Remember, the final quality of your concrete surface can only be as good as the formwork you build. Now for the skeleton of your slab, the steel reinforcement, or rebar. Concrete is strong in compression but weak in tension, and it's this steel that gives it the tensile strength it needs. Your structural engineer's drawings are your Bible here. First, verify that the correct diameter of rebar is being used. A 12mm bar cannot be substituted for a 16mm bar without approval. Next, check the spacing. Use a measuring tape to confirm that the distance between bars matches the design specifications, both for the main bars and the distribution bars. Inconsistent spacing creates weak spots. Pay critical attention to cover. This is the minimum distance between the rebar and the edge of the concrete. It's essential for protecting the steel from corrosion. Use concrete spacer blocks, often called chairs, to lift the rebar mesh off the formwork and ensure adequate cover on all sides. Where bars need to be joined, ensure the lap lengths are correct as specified in the drawings. These overlaps must be securely tied with binding wire to ensure a continuous transfer of force. A final check involves walking the grid. It should feel firm and solid underfoot, with no excessive movement or sagging. With the reinforcement in place, it's time to integrate the building services. This includes all electrical conduits, plumbing pipes, and any other sleeves that need to pass through the slab. Coordination at this stage is crucial to avoid costly mistakes. All conduits and pipes must be laid out according to the mechanical and electrical plans. Ensure they are positioned correctly, avoiding clashes with structural elements. A pipe running through a beam's critical stress area can compromise its integrity. All services must be securely fastened to the reinforcement grid. Wet concrete is heavy and will exert a powerful upward force, causing unsecured pipes to float to the surface. Use plenty of binding wire to tie them down firmly at regular intervals. For plumbing, double-check that all waste pipes have the correct fall or slope to ensure proper drainage later on. It's also wise to pressure test water pipes before the pour to detect any leaks. Once the concrete is cast, fixing a leaking pipe is a nightmare. Finally, mark the locations of all junction boxes and future connection points clearly on the formwork, so they can be easily found after the pour. The strength of your slab is determined by the quality of the concrete itself. Achieving the right concrete mix is a science. Whether you're batching on-site or ordering ready mix, you must be vigilant. The mix design specifies the precise ratio of cement, sand, aggregate, and water. For on-site mixing, this means using a consistent measuring system, like a head pan or a marked bucket, not just shovels. This is called volume batching. The most critical element is the water-cement ratio. Too much water creates a weak, porous concrete that's prone to cracking. Too little and it becomes unworkable. The goal is to use the minimum amount of water required to make the mix workable. A simple on-site quality check is the slump test. This measures the consistency and workability of a fresh batch of concrete. A consistent slump from batch to batch indicates a consistent mix. If your design calls for admixtures, chemicals that can accelerate or retard setting time, or improve workability, ensure they are added in the correct dosage as per the manufacturer's instructions. Never compromise on the quality of your materials. Your cement should be fresh and your aggregates clean and well graded. With all checks complete, the pour can begin. But even this stage requires careful management. The placement of concrete should be systematic. Start from the farthest point and work your way towards the access point to avoid walking over freshly laid concrete. Pour the concrete as close to its final position as possible to avoid overhandling, which can cause segregation of the materials. As the concrete is placed, it must be compacted immediately to remove trapped air pockets or voids. The most effective method is using a poker vibrator. The vibrator should be inserted vertically into the concrete at regular intervals and withdrawn slowly. You'll see air bubbles rising to the surface. Be careful not to over-vibrate, as this can also cause segregation. A key goal is to avoid cold joints. This happens when one batch of concrete starts to set before the next batch is poured against it, creating a weak plane. The entire pour should be a continuous operation, completed as quickly as possible without interruption. This requires good planning and coordination between the mixing team and the placement team. As soon as the concrete is placed and compacted, the finishing process begins. The first step is screeding. This involves using a long, straight board to strike off the excess concrete and bring the surface to the required level. Following screeding, while the concrete is still plastic, a bull float is used. This is a large, long-handled float that is pushed and pulled across the surface to embed the large aggregate, smooth out any imperfections left by the screed, and bring a layer of mortar to the surface. Timing is everything in finishing. After the bleed water has evaporated from the surface, the final troweling can begin. Using a steel hand trowel, the finisher works the surface to create a smooth, dense, and durable finish. This may need to be done in several passes as the concrete continues to set. Pay special attention to the edges and corners, ensuring they are clean and well-defined. A well-finished slab is not only aesthetically pleasing, but also more resistant to wear and abrasion. The job isn't over once the finishing is done. Curing is the final, vital step that ensures the concrete reaches its full design strength. Curing is the process of maintaining adequate moisture and temperature in the concrete for a period of time. If a slab dries out too quickly, the hydration process stops, and the concrete will be weak and prone to shrinkage cracks. There are several methods for curing. The most common is water curing, which involves keeping the surface continuously wet by ponding, spraying, or covering it with wet materials like Hessian sacks. Another effective method is to cover the slab with plastic sheeting immediately after finishing to trap the bleed water. Curing should continue for a minimum of 7 days, and longer in hot, dry, and windy conditions. During this period, the slab must be protected from premature loading. Don't allow heavy materials to be stacked on it or heavy foot traffic. A properly cured slab is a strong slab. Throughout this entire process, from site prep to curing, professional supervision is non-negotiable. A A qualified engineer or an experienced site supervisor must be present to oversee the work and ensure every step is executed correctly. They are your quality assurance. This supervisor should be armed with the structural drawings and a comprehensive checklist, methodically signing off on each stage before the next begins. Has the formwork been checked for level and stability? Is the rebar cover correct? Has the slump test been performed? This formal sign-off process creates accountability and minimizes the chance of errors being overlooked in the rush of a construction site. The supervisor's role is to enforce standards, solve problems on the spot, and make the final call on whether the site is truly ready for concrete. Their expertise is the final guarantee that your slab will be built to last. And there you have it. A solid, well-executed concrete slab, the result of careful planning, meticulous checks, and professional execution. By following these steps, you're not just building a floor, you're investing in the quality and safety of your entire project. If you found this guide helpful and want to learn more about building smarter in Nigeria, make sure to subscribe to our YouTube channel, like this video, and hit the notification bell so you never miss an update. Build smart, build safe, build to last.